Let's solve problem 10 on the 2024 Math in the Matrix competition power round. For I is equal to 1, 2, 24 squared, denote xi as the smallest positive integer such that ixi is a perfect square. If p is the product of all xi, find the number of not necessarily distinct prime factors of the square root of 576 factorial over p. Okay. Let's define a new sequence, AI. Let's just say AI is equal to I over xi for all i's between 1 and 576, which is 24 squared. Notice that 576 factorial over p is equal to the product of all AI. Why? Because that's equal to a1 times a2 times a3 times times a576, which is equal to 1 over x1 times 2 over x2 times 3 over x3 times times 576 over x576, which is 576 factorial over p. Okay, now we have that AI notation down. Let's try solving this problem. Notice that we can write all values of I as c squared times d, where c is maximized. So I claim that AI is equal to c squared. Okay. So why is this? Well, we know that xi has to be equal to d, so that I times xi is a perfect square, namely c squared d squared. So then I over xi would be c squared times d over d, which is c squared. So that's this. And so basically, root of 576 factorial over p is basically equal to the product of all c. Okay, now how do we find the product of all c? We know that c is basically just the square root of the largest square that divides a specific positive integer. Let's just say, for example, that 2 squared divides I. Then, remember that we're finding the number of prime factors. So this, how many factors of c does that contribute? Well, there's 144 numbers of I that are multiples of 4, namely 4, 8, 24 squared. So this contributes 2 to the 144 to the final product. Because c is equal to 2, 2 is a factor of c for all of those multiples of 4. Okay, what about if 3 is a factor of c? Then 9 divides I, and there's going to be 576 over 9, which is 64 positive integers that satisfy this. And so this is just going to be 3 to the power of 64. It's going to contribute 64 prime factors to the product of all c values. And let's do the same thing for 4. 4 squared divides I. Then that means that how many values of this? They're 576 over 16. What is that? That is going to be 36. So this is going to be 4 to the power of 36. But is it really? But we've already counted. When c is a multiple of 2, we've already counted that. So we've counted one prime factor of 2. But we need to count another prime factor of 2 if c is a multiple of 4. So this, in reality, is just 2 to the power of 36, because we have already counted some here. And 5 squared divides I. We can do the same thing. This is equal to 23, because 24 squared is equal to 576, and 23 times 25 is equal to, that's going to be equal to 575. Okay, so this is going to contribute 5 to the power of 23 to the final product of i's. But what about 6? Notice that we don't need to count the times where 6 is a factor of c, because we've already counted that in the 2's and the 3's. It's only if we're introduced a higher factor. So we only want to count the values that are primes or perfect powers of a prime. Now we know this, so this contributes 144 prime factors, this contributes 64, this 36, this 23, and so on. If we add all of these numbers up to the last one's 23 squared, then we're going to get 306. And 306 is our final answer. That's it for this problem.